Imagine gazing up at the velvet expanse of the night sky, and one of its most majestic and familiar beacons, the colossal Jupiter, is simply gone, vanished. What if this titanic gas giant, a silent sentinel of our solar system for billions of years, were to suddenly dematerialize? The ramifications would be far more profound and far-reaching than you might ever conceive, impacting not just our cosmic neighborhood, but potentially every living thing on our own blue planet. This isn't just about a missing dot in the sky. It's about the unraveling of a cosmic order. The very first, and most terrifying, consequence of Jupiter's instantaneous disappearance would be the creation of an immense gravitational abyss. Jupiter, a true titan among planets, possesses a staggering mass of approximately 1.898 times 1027 kilograms. To put that into perspective, it's over 318 times the mass of Earth and, astonishingly, more than 2.5 times the mass of all the other planets in our solar system combined. This gargantuan mass generates an incredibly powerful gravitational field, a cosmic tether that profoundly influences everything in its vicinity, from the stately orbits of its planetary neighbors to the erratic trajectories of countless comets and asteroids. If Jupiter were to wink out of existence, its colossal gravitational pull would instantly cease. This sudden absence would plunge the delicate orbital mechanics of the outer solar system into immediate and unprecedented chaos. Visual, a dynamic animation of the outer solar system, showing Jupiter's initial position and then its sudden disappearance, followed by other planets wobbling. Saturn, Uranus, and Neptune, currently held in stable, resonant orbits partly due to Jupiter's massive influence, would experience a sudden shift. Their paths around the Sun, once predictable, would rapidly become significantly more eccentric, elongated, and utterly unpredictable, potentially leading to future close encounters and even ejections from the solar system over vast timescales. One of Jupiter's most critical, yet often unappreciated, roles is its mastery over the asteroid belt, a vast donut-shaped region located precisely between the orbits of Mars and Jupiter, estimated to contain millions of rocky bodies larger than 1 kilometer. For eons, Jupiter's immense gravity has acted as a benevolent, yet firm, cosmic shepherd. It has skillfully prevented these countless asteroids from coalescing into a full-fledged planet and, perhaps more importantly for us, its resonant gravitational perturbations have effectively cleared out many potentially Earth-crossing orbits, nudging countless rocky fragments away from paths that would otherwise bring them into the densely populated inner solar system. Think of Jupiter as a diligent cosmic vacuum cleaner, tirelessly maintaining a degree of celestial tidiness. Without Jupiter's pervasive gravitational influence, the delicate stability of the asteroid belt would utterly collapse. Millions upon millions of asteroids, once held in relatively stable orbits, would be liberated from Jupiter's control. Many would be gravitationally perturbed and sent hurtling inwards, dramatically increasing the probability of devastating impact events with Earth, Mars, and our other inner terrestrial planets. We would undoubtedly witness a cataclysmic escalation in meteor showers, with fireballs blazing across our skies on a regular basis. More ominously, the risk of genuinely civilization-altering collisions, events capable of triggering global dust clouds, tsunamis, and widespread extinctions, would skyrocket by orders of magnitude. Imagine the Chicxulub impact, but far more frequent. Moving further out into the frigid reaches of our solar system, Jupiter's protective influence extends to comets originating from the incredibly distant Oort cloud and the closer, yet still remote, Kuiper belt. These vast reservoirs are home to billions, if not trillions, of icy bodies, remnants from the early solar system. If left undisturbed, these frozen wanderers could easily be drawn into the inner solar system by the Sun's gravity, posing an even more formidable threat than asteroids due to their far greater velocities, sometimes reaching hundreds of thousands of kilometers per hour. Jupiter's gravity, however, acts as a sophisticated cosmic slingshot, masterfully deflecting many of these potentially hazardous comets away from the inner planets or even capturing them into much shorter, less threatening periodic orbits, making them predictable visitors, like Halley's Comet. The sudden disappearance of Jupiter would irrevocably dismantle this crucial protective shield, leaving the inner solar system brutally exposed. A significantly greater number of long-period comets, those on orbits that can take thousands or even millions of years, would be free to penetrate the inner solar system, their paths untamed. The night sky might transform into a dazzling, yet utterly terrifying, spectacle of intense cometary activity, with brilliant tails streaking across the heavens. The potential for catastrophic cometary impacts, events capable of delivering unimaginable energy and volatile compounds, would become a stark and ever-present danger. dwarfing the asteroid threat. This would be a cosmic shooting gallery, and Earth would be a primary target. While Jupiter's direct gravitational tug on Earth's immediate orbit is indeed less pronounced than that of the Sun or even our Moon, its long-term, subtle stabilizing effect is absolutely crucial for the sustained habitability of our planet. Over timescales stretching tens of thousands to millions of years, Jupiter plays a vital role in dampening the orbital eccentricities and the axial tilts of the inner planets, including Earth. It helps to ensure that our planet's orbit remains relatively circular and that its tilt doesn't vary wildly. Without this crucial stabilizing force, Earth's orbital path might gradually become more elliptical, leading to increasingly extreme variations in our distance from the Sun throughout the year, which would intensify seasonal extremes. More profoundly, Earth's axial tilt, the 23.5-degree tilt that gives us our precious seasons, could experience much larger and more erratic fluctuations over geological timescales. This could trigger more dramatic and unpredictable climate shifts, potentially ushering in severe ice ages that encompass much of the planet, or conversely, periods of intense and rapid global warming, occurring on a much faster and more devastating timescale than the current climate crisis. Our exquisitely finely tuned climate system, the very foundation upon which all complex life depends, would be thrown into profound disarray, challenging the adaptability of even the most resilient species. Jupiter isn't merely a gravitational behemoth. It's also a powerhouse of magnetic field generation. Its incredibly strong magnetic field, over 20,000 times more powerful than Earth's, creates an enormous magnetosphere, a vast bubble of plasma that extends millions of kilometers into space. This colossal magnetosphere acts as a gigantic cosmic trap, capturing and accelerating charged particles from the solar wind and beyond, forming the intensely energetic radiation belts that encircle the planet. Crucially, this magnetosphere acts as a colossal shield, deflecting the vast majority of harmful cosmic rays and energetic particles originating from distant supernovae and other violent astrophysical phenomena, preventing them from penetrating deeply into the inner solar system. Visual: a diagram showing Jupiter's magnetosphere deflecting cosmic rays away from the inner solar system. Without Jupiter's immense magnetosphere, the inner solar system, including Earth's orbital path, would be exposed to significantly higher and more constant levels of cosmic radiation. This increased radiation flux would pose a serious and continuous threat to unshielded future space missions, making long-duration human travel beyond Earth's protective atmosphere far more dangerous and challenging. While Earth's own robust magnetic field and thick atmosphere offer substantial protection to life on the surface, a persistent increase in background cosmic radiation could, over very long timescales, subtly impact the delicate balance of ecosystems and perhaps even influence mutation rates, though the immediate, catastrophic effects on ground-level light would likely be minimal. It would, however, make space exploration exponentially more hazardous. Beyond the individual direct impacts, Jupiter's disappearance would fundamentally alter the entire gravitational symphony of our solar system. The planets are not isolated bodies. They constantly exert subtle gravitational tugs on each other, maintaining a delicate, billions-of-years-old dance. Jupiter, being the most massive player, is the conductor of this celestial orchestra. Its regular, predictable pull provides a stabilizing influence on the barycenter, the center of mass of the entire solar system, which slightly shifts as the planets orbit the Sun. Without Jupiter, this barycenter would shift significantly closer to the Sun, and the entire system's stability would be compromised. The long-term orbital resonances, which involve precise relationships between the orbital periods of planets e.g. Jupiter and Saturn had a near 2-to-5 resonance, would break down. This could lead to a gradual increase in orbital instabilities, potentially causing the long-term ejection of other planets from the solar system, or even collisions, over geological timescales spanning hundreds of millions or billions of years. The solar system, as we know it, would literally begin to unravel, albeit slowly, into a far less orderly arrangement. Beyond the tangible physical ramifications, Jupiter's disappearance would cast an immeasurable psychological and scientific shadow over humanity. For millennia, Jupiter has been a brilliant beacon in our night sky, a source of profound awe, inspiration, and relentless scientific inquiry. Its swirling clouds, its iconic Great Red Spot, and its Galilean moons have captivated astronomers and laypeople alike, serving as a constant reminder of the vastness and wonder of the cosmos. Its sudden absence would be a chilling, stark, and undeniable reminder of our minuscule scale and the frightening fragility of the delicate balance that governs our solar system, an existential shock to our collective consciousness. Scientifically, The loss of Jupiter would represent an irreplaceable void. It would deprive us of an unparalleled natural laboratory for studying the fundamental processes of planetary formation, the intricate dynamics of gas giant atmospheres, the evolution of massive planetary systems, and the conditions for the emergence of complex chemistry within an icy moon's ocean. Imagine the millions of hours of telescopic observations, probe missions like Juno and Galileo, and theoretical models that have been dedicated to understanding Jupiter. All that immediate access to data, to a planet that offers unique insights into the very earliest moments of our solar system's birth, would be gone. It would leave a gaping, unfillable hole in our understanding of how solar systems form, function, and evolve, setting back astronomical, planetary, and astrobiological research by not just decades, but potentially centuries. The sheer volume of unanswered questions would be staggering. In the truly long term, spanning millions to billions of years, the solar system would evolve into a vastly, almost unrecognizably, different place. The orbits of the remaining gas giants, stripped of Jupiter's stabilizing hand, would eventually settle into new, almost certainly less stable and more eccentric configurations. The inner solar system would transform into a far more perilous environment, under constant threat from a relentless, increased bombardment of stray asteroids and long-period comets, making the prospect of long-term survival for any advanced civilization far more challenging. Life on Earth, if it managed to persist through the increased impact risks and climate shifts, would exist in a harder, more precarious, and less predictable cosmic environment. The magnificent cosmic ballet that has unfolded for over 4.5 billion years. A meticulously choreographed dance of celestial bodies carefully orchestrated by the Sun and its planetary companions, with Jupiter as the lead dancer and gravitational anchor, would be forever altered. It would become a more chaotic, less harmonious performance, a powerful and humbling testament to the immense and often unappreciated fundamental role of the gas giant Jupiter in sculpting and safeguarding our home. So, what, truly, would happen if Jupiter disappeared? In sum, it would unleash a cascading series of catastrophic events that would reverberate throughout the entire solar system, fundamentally transforming our cosmic neighborhood from a remarkably stable and life-friendly system into an inherently chaotic, far more dangerous, and unpredictable realm. Jupiter is far more than just the largest, most visually impressive gas giant. It is, unequivocally, a cosmic guardian, silently, tirelessly, and effectively protecting Earth and the inner planets from a constant, otherwise overwhelming barrage of celestial threats. Its sudden, unimaginable absence would starkly underscore just how exquisitely interconnected and interdependent our solar system truly is. It would reveal, in the most dramatic fashion possible, how the very presence and specific properties of each planet, particularly the monumental Jupiter, are absolutely crucial for the long-term stability, evolutionary trajectory, and ultimately, the continued habitability of our precious home planet. Let us therefore appreciate and be profoundly grateful for this magnificent, unsung protector, diligently watching over us from its majestic perch in the outer solar system, a silent colossus holding the cosmic order in nouns. So, what, truly, would happen if Jupiter disappeared? In sum, it would unleash a cascading series of catastrophic events that would reverberate throughout the entire solar system, fundamentally transforming our cosmic neighborhood from a remarkably stable and life-friendly system into an inherently chaotic, far more dangerous, and unpredictable realm. Jupiter is far more than just the largest, most visually impressive gas giant. It is, unequivocally, a cosmic guardian, silently, tirelessly, and effectively protecting Earth and the inner planets from a constant, otherwise overwhelming barrage of celestial threats. Its sudden, unimaginable absence would starkly underscore just how exquisitely interconnected and interdependent our solar system truly is. It would reveal, in the most dramatic fashion possible, how the very presence and specific properties of each planet, particularly the monumental Jupiter, are absolutely crucial for the long-term stability, evolutionary trajectory, and ultimately, the continued habitability of our precious home planet. Let us therefore appreciate and be profoundly grateful for this magnificent, unsung protector, diligently watching over us from its majestic perch in the outer solar system, a silent colossus holding the cosmic order in nouns. If you found this cosmic deep dive as fascinating as we did, make sure to hit that like button, subscribe to our channel for more mind-blowing space facts, and let us know in the comments below what other celestial what-ifs keep you up at night. We'd love to hear your thoughts.